Hello everyone. So let us discuss about thermodynamics, chemical engineering thermodynamics, its significance and importance in engineering and why thermodynamics is called as heart of engineering or heart of chemical engineering. So experience the essence of it through the applications it has. So let us take a dive. For the next 2 minutes, I would like you to realize the thermodynamics importance in daily life applications. So moving on, what is thermodynamics actually? What actually thermodynamics defines? It is a study of transferring of energy here and there. If you look at it, nuclear energy, solar and wind energy, hydro energy, and thermal energy, there are different forms of energy where energy is getting transferred. If you take nuclear energy, it all starts with an atom, a nucleus, which makes up the matter in the universe. So the nuclear energy starts generating through the splitting of atoms, which is called fission process, right? Fission process, and it generates heat and make turbine to rotate, and electricity is generated again. So transferring of one energy to the other form. If you take wind and solar energy, the heat is absorbed by the solar panel, and the process happens, and again electricity is generated. If you take wind energy is making use of the turbine to rotate, and electricity is getting generated by converting kinetic energy to electrical energy. And if you heat a body, if you boil milk or if you boil water or heat any material, the heat is transformed from hot body to cold body, as we all know. So through different process, conduction, convection, and radiation takes place, which is again energy is getting transferred, thermal energy. It is called as thermal energy. And if you take hydro energy, there is a cycle between water and vapor. So water is getting evaporated, and again thin cloud formation, and again condensation, precipitation, and again water forms, right? So it's a cycle where energy is getting transferred. So these are all different conversions of energy we see, where thermodynamics is playing a crucial role, or directly or indirectly. So obtaining energy, transferring energy, and applying energy is what thermodynamics deals with. Here we mainly focus on mass, energy conservation principles, first law and second law of thermodynamics. So moving on, what is the functionality or functioning of thermodynamics? So according to the thermodynamics H.C. Vannes, he says it is the function of thermodynamics to relate those properties of a system required for practical or theoretical purposes to the parameters that are most readily measured, and thus to provide the maximum return of information for any investment in the experiment. So it is required to establish a relation between practical or theoretical purposes to the thermodynamics parameters. So when you start analyzing the process, it is required to know what are all the thermodynamic parameters are involved in it, so that we can easily analyze. So we can get the whole information or the whole analysis of the process. And according to the physicist Lord Kelvin, thermodynamics is a subject of relation of heat to the forces acting between contiguous parts of bodies, and the relation of heat to electrical agencies. When you take different parts of bodies, like consecutive parts of bodies, the heat is if you establish a relation between the heat to force and electrical agencies, like as we see in nuclear energy or solar or wind energy. So the heat is converted to electrical energy. So it's again transferring of energy from one form to another form, or one body to another body. So the transferring of energy and the functioning of thermodynamics is what the conversion of energy. And when you talk about scope of thermodynamics, there is the scope is very vast. So if you talk, thermodynamics is not new. The science of thermodynamics was born in 19th century to describe the steam engine, to describe the operation of the steam engine, and the heat. The name itself defined the power developed from the heat with obvious application of heat engines. Then the time when the scope of thermodynamics was discovered, like science of thermodynamics was discovered, they generalized these principles as laws of thermodynamics. Whatever the principles they have observed, they generalized those into the laws of thermodynamics, which we are reading now as first law of thermodynamics and second law of thermodynamics, where first law deals with the conservation of energy. Neither energy is created nor be destroyed. And second law deals with entropy, which we say measure of disorderness or the amount of energy unavailable for the work. So these two laws have no proof in mathematical sense, but they are universally observed to be obeyed. And that's how the scope of thermodynamics is vast. And why to study thermodynamics? To be frank, thermodynamics is everywhere. So if you take these examples shown up in the figure, the region is crowded with many people. You feel warm and summer. Why you feel warm? Because thermodynamics is there. When you feel warm, the heat is generated from the body and sweating starts. So this sweat absorbs heat from your body and it evaporates, and that's how heat ejects from your body and the environment becomes warm. And if you take ice, so ice is we can form ice when the temperature of the ice is maintained below the freezing point of water, right? So when the ice is dipped in the water, it gets melts. Even though the heat is same, the temperature of the ice and the water becomes equal. The equilibrium starts existing. So that's where thermodynamics again comes into the picture. And if you take heart, the heart pumps blood to the entire body parts. So the entire body parts, the conversion, many energy conversion takes place within the millions of cells in our body, right? So the heat is getting rejected by our body. So due to which the human comfort is decided by the amount of heat generated by the body to the environment. So according to that, we use clothes. In winter, we use different clothes. In summer, we use different clothes, because the conversion, the heat, how much the heat is getting rejected, how much the heat is getting absorbed from the body is decided by thermodynamics, knowingly or unknowingly. And you take different applications, you take air conditioners and you take refrigeration systems. Everywhere thermodynamics is hidden and heat is getting transformed. Power plants, human body, car radiators, aeroplanes, and everywhere thermodynamics is essential to understand, to able to know the real life applications, to be able to visualize the world with thermodynamics. It is necessary to have a knowledge of thermodynamics. So it is required, or it is needed, or it is mandatory thing to know the importance of thermodynamics in chemical engineering. And it's just an introduction part where we looked at the thermodynamics and all different applications. So thank you. Let's upskill the thermodynamic skill and rule the world with engineering.